Hi, this is Chintan Patel. In this lecture, we are going to look at the graphical method to solve the principal stresses that are occurring on any element or the body. So, this graphical method is based on Mohr circle. Mohr circle is the one method by which you can calculate any principal stresses that is acting or occurring in on any plane in the body. So we can also find out the normal stresses or the direct stresses or the tangential stresses occurring in the body. So let's get started with the basic theory of the Mohr circle. To get started, we also need to understand the sign convention of the Mohr circle. To draw the Mohr circle, these are the sign convention that you need to understand before starting understanding the method. So first one is draw sigma 1 always on the right side of O point. Now let me just draw everything over here so that you guys can understand. Let's say we are taking a reference axis like this. This is our vertical reference axis and this is our horizontal reference axis. So the origin point or this center point will be our O point. So what they are saying is you have to draw sigma 1 on the right side, on the right portion of the O. So this means it's in the first quadrant only. So that's our first rule that we need to follow. Second is if the nature of the sigma 2 is similar to sigma 1. So if both are tensile or both are compressive, then draw sigma 2 also on the right side. So if both are having the same nature only, then we have to draw them both on the right side. If the sigma 2 is of the opposite nature to the sigma 1, then we must draw sigma 2 on the left side of the O. So if it is of opposite nature, it is simple that you need to draw it on the left side. Next sign convention, if tau is positive, we have seen that which type of a shear stress is considered as a positive and which type of a shear stress is considered as a negative in the previous chapter. If you have not seen that videos, then I would recommend you to see those videos so that you guys can understand which one is positive and negative. So if it is the positive shear stress, then draw below the OX line. Draw below the OX line. And if it is the negative shear stress, then draw above the OX line. Now, which one is the OX line? This is our X and this is our Y. So, below the OX line and above the OX line. It should be clear by now. Next is theta. If the theta is measured clockwise from the reference vertical axis, then it is considered as a positive. And then measure 2 theta. Instead of theta, we are measuring over here 2 theta. 2 theta above the OX line. Above the OX lines means in this quadrant. After that, if it is the negative, then we have to measure the 2 theta below the OX line. Now, shear stress is, if the shear stress is acting, if externally we are applying a shear stress, CA dash line represents the vertical plane. CA dash lines would be over here somewhere like this. So this CA dash line represents the vertical plane or line represents the plane which is indicating the shear stress. Okay. Now theta is positive, then measure 2 theta above CA dash line. And if theta is negative, then measure 2 theta below the CA dash line. Now if the sigma t is above the OX, then it is positive, and if the sigma t is below the OX, then it is negative. Now these are the basic terminologies that you need to understand. We will see these terminologies applied in our examples also, so that you don't get confused over here. But I would recommend you to understand those terminologies so that you can understand the procedure to draw the Mohr circle. First of all, we are drawing a Mohr circle to find a sigma n, sigma t and a sigma resultant on any inclined plane by the Mohr circle. So one direct stress is acting on the body is the case that we are discussing over here. This is our case number 1. Later on we can go for another cases using the same method. So you can see that diagram of the body which is subjected to a direct stress sigma 1. So over here you can see that sigma 1 is acting on the body like this, and this is the only stress which is acting on the body. There is no other stresses in the vertical direction, or any shear stress is not acting on the body. So we are intended to find out the sigma and sigma t and sigma r on this EF plane. This is our EF plane. Now this EF plane is located at the theta angle. Now this angle is measured along the clockwise direction. So as this is a clockwise, so our angle is positive, theta is positive. So we will consider 2 theta is also positive. Okay. So now what we will do, we will go for the a list of the stresses that we have seen over here. Sigma 1 is the direct stress, theta is the angle of inclined plane, sigma L is normal, sigma t is tangential, and sigma r is resultant stress. So first what we will have to do, we will have to go for suitable point 0, or let's say we are taking two axes, this one red vertical axis and this one as a horizontal axis. So we have taken the vertical axis like this. So OX is our horizontal axis, and let's say this OY is our vertical reference axis. Okay, so in this case we have only one stress sigma 1, we don't have any sigma 2. So first of all, whenever we draw sigma 1 in our diagram, we have to draw it on the right side of the O point. So as you can see over here, we have represented sigma 1 by using the suitable scale at A point. Let's say sigma 1 is 10 Newton per mm square. Okay, so we will take the scale according to our adjustment possible. So we can take the scale like 1 centimeter equals to 10 Newton per mm square, or 10 centimeter equals to 10 Newton per mm square, according to our requirement. So let's say we have taken 1 centimeter equals to 10 Newton per mm square. So we will measure 1 centimeter from O point. So from here we will measure 1 centimeter, and at 1 centimeter we will plot A point. Now this A point will represent the value of sigma 1. This is our sigma 1, right? Now as there is no sigma 2, there is no need to identify whether it is on the right side or on the left side. So this is our sigma 1 OA point, that's it. Then what we will do, we are going to cut OA equal to sigma 1 to some suitable scale. We have done it already. Bisect the OA at C. So we have bisected the OA at C point over here. This is our C point. Okay. Now C as the, consider C as the center and CA or CO as the radius. So we have taken this as a center and CA is as a radius, and we have drawn a circle. So this circle is known as the Mohr circle. So through C point, draw a line CP, making an angle 2 theta with CX. So we have taken the 2 theta angle with CX line. So as you can see, we have taken the angle above the CX line, as per our sign convention. So at 2 theta angle, we have represented the CP line. So this is our CP line at a 2 theta angle. Now this CP line is representing the EF plane in our body. Through the P point, draw PQ perpendicular to OA. So this is our Q point. So we have drawn PQ, which is perpendicular to the OA line. Now measure from the triangle OQP. Which one is the triangle OQP? This is our right angle triangle OQ and P. Right angle triangle OQP, right? So OQP to the scale, that sigma n equals to OQ. Now this sigma n is equals to OQ. So we need to find out this much length. Let's say this length is coming out to be 0.75 centimeter. So let's say it's a 75 mm, right? So what we will consider for the in the case of the Newton per mm square, we have taken 1 centimeter as a 10 Newton per mm square. So for 0.75 centimeter, we can take 7.5 Newton per mm square. Similarly, you can find out the sigma t equals to PQ. So PQ is our sigma t. Why is it so? Now remember this one thing very clearly. So whenever you are drawing a Mohr circle, on the horizontal line, you will represent a direct stresses, and on the vertical line, you will represent tangential stresses. So tangential stress or shear stresses are represented vertically. So anything you measure vertical direction is always representing a tangential stress, and anything that you measure in the horizontal direction will represent a direct stress. Okay, so we have measured OQ horizontally, that's why it is our normal stress. We have measured PQ vertically, that's why it is our tangential stress. Now let's say if you want to find out resultant stress, then measure OP. Measure OP. This much length will give you the answer of the resultant stress. And converting all this length into according to our scale, we will get the answer in terms of the Newton per mm square or Newton per meter square. POA is pi angle, that is known as angle of obliquity. Now what is this angle? This is the angle between the resultant stress and normal stress. This is the angle between the resultant stress and normal stress. So these are the things that you can calculate using the basics of Mohr circle. There is more coming in the upcoming slide, so that keep paying attention over here. So we are going to discuss this case number 2. So let's say this is our case number 2, where the body is subjected to two direct stresses on perpendicular planes. So here the first stress is sigma 1 and the second stress is sigma 2. Both the stresses are acting on the body. We need to find out the sigma n, sigma t and sigma r on this plane EF, which is located at the theta angle from the reference vertical line. So what are we going to do? We are going to draw two axes. First of all, two axes, both the axes from the O point. So let's say this is our vertical axis and this is our horizontal axis X. On the horizontal axis, we will represent direct stress. On the vertical axis, we will represent shear stress or tangential stress. Both are the same. Tangential stress and shear stress, both are the same. Now we will draw sigma 1 on the right side first. So let's say sigma 1 is the bigger value. So this much length is, according to our scale, is sigma 1. So we have plotted a point over here on the horizontal axis. As you can see, sigma 2 is also of the same nature of the sigma 1. Sigma 1 and sigma 2 both are of the tensile nature. That's why we will represent sigma 2 on the right side only. But the value of sigma 2 is less than the sigma 1. That's why this length is shortened or the shorter as compared to sigma 1. So we will plot point B over here. So we have plotted 2 points until now, A and B. Now what are we going to do? We are going to join AB, okay, and bisect it exactly in the middle. So this is our C point from the bisection. So C point will act as a center and we will consider CA or CB as our radius and we'll draw a circle. So let's say this is our circle. Now what we'll do, CA or CB as our radius and draw a circle. Then through the C, draw a line CP making an angle of 2 theta with CX. So with this CX line, we will calculate a 2 theta angle and draw a CP line like this. Now from this P point, if you draw perpendicularly this much distance or PQ point, then this Q point will represent the normal stress distance. So OQ distance will give you the answer of the normal stress. Similarly, if you calculate this distance or OP distance, it will give you the answer of resultant stress. And if you calculate vertical distance, that is PQ distance, that will give you the answer of sigma T, that is also known as the tangential stress. So measuring all three distances will give you the answer that we require to find out from the Mohr circle. Angle POA is again the angle of obliquity, which is the angle between the normal stress and resultant stress. So this is how we are going to draw a Mohr circle to find out the normal stress, tangential stress and resultant stress. In the upcoming lecture, we will see that examples or numericals based on this graphical method, and we will try to find out the principal stresses as well as the normal stresses and tangential stresses. So this is how we conclude our lecture over here. Till then, thank you.